Good day everybody, we got this question. We expected to integrate this. Foremost what I wish to do is I would like to take e raised to the power of x to be equal to some t. I differentiate this, I get e raised to the power of x dx is equal to dt. Now this is log to the base e. So when I have x is equal to negative log 2 to the base e raised to the power of negative log 2 to the base e can be rewritten as e raised to the power of log 2 raised to the power of negative 1 to the base e, which is nothing but, because this is already log e, right, and you have a base to be as e here. So this is going to be 2 raised to the power of negative 1, which is going to be 1 over 2. Now this is the value for t. So when x takes this value, t takes the value 1 over 2. So that's the very important limit adjustment. So for x is equal to log 2 to the base e, t will be equal to 2. So that is quite obvious from the way in which we have set t. So if I were to take this as 1, therefore I can rewrite 1 to be as integral 1 over 2 to 2. Now e raised to the power of x dx is dt. So my dt will be here, followed by log, of course base is e, of e raised to the power of x is t positive the root of 1 positive e raised to the power of x. E raised to the power of x is t, e raised to the power of 2x is t squared. So this is what we have got, and we will have to integrate this. Now what I wish to do is I will take u to be equal to log of t positive root of 1 positive t squared. Whenever I mention log, it is understandable that we are dealing with to the base e in this problem. So you differentiate this, you get 1 over t positive root of 1 positive t squared multiplied with the differentiation of this quantity. So this is going to give me 1 positive differentiation of root of 1 positive t squared. That's going to be 1 over 2 times 1 positive t squared raised to the power of negative 1 over 2 multiplied with the differentiation of t squared, which is going to be 2t times dt. So this can be further rewritten as 1 positive 2 times t. I can push this down, so this is going to be root of 1 positive t squared. There's already a 2 there, you can write that 2. Now this is product multiplied with 1 over t positive square root of 1 positive t squared times dt, right? So taking integration by parts, uv negative integral v du. What is my u? My u is this quantity, log of t positive root of 1 positive t squared. My v, what is my v? We need to set that. So from here dv is equal to dt, my v will be equal to t. So v is t, the limits are 1 over 2 to 2 followed by negative integral v is t du is going to be this entire component. Okay, so I will place this t positive root of 1 positive t squared first multiplied with 1 positive 2t over 2 times root of 1 positive t squared times dt. Limits are 1 over 2 to 2. Now let me go to the next page. Now this is what we have got. Okay, now you substitute the upper limit, you get 2 times log of 2 positive root of 1 positive 2 squared is 4, 4 positive 1 is 5. This is for the upper limit, minus, in fact I can take okay, I cannot take this 2 out. I thought I can take the 2 out. No, so we need to retain it in this fashion, followed by 1 over 2, right? 1 in place of t I substitute 1 over 2 times the log of 1 over 2 positive 1 over 2 squared. That's going to be 1. This is going to give me 1 positive 1 over 4. That's going to be 5 over 4. So root of 5 over 2. We can write it like this. So this is what we have got. Now this is followed by negative integral 1 over 2 to 2. Now you can simplify this quantity, right? So if you were to simplify, let me show you the simplification. See, this LCM is going to be 2 times the root of 1 positive t squared. So this is going to be 2 times the root of 1 positive t squared positive 2t times t over t positive root of 1 positive t squared, right? I can take 2 out. This is going to be t positive root of 1 positive t squared divided by 2 times the root of 1 positive t squared, and you have a product multiple of t over t positive root of 1 positive t squared. Now this and this cancels, this and this gets cancelled, giving me t over root of 1 positive t squared. So this is what we have for the integral. So this is going to be t over root of 1 positive t squared times dt. Now I can rewrite this as log 2 positive root of 5 squared. I can rewrite this log of 1 positive root of 5 divided by 2 raised to the power of 1 over 2. Okay, fair enough. Okay, so what I can do with this 1 over 2 comes all over, right? This is going to be covering this entire component, followed by negative 1 over 2 to 2 t dt divided by root of 1 positive t squared. I'm going to use ln of a negative ln of b, which is ln of a over b. So this is going to be log, they have given it as log, so I'm retaining it as log. The base is e. So it's going to be 2 positive root of 5 squared divided by square root of 1 positive root of 5 divided by 2 negative 1 over 2 to 2 t dt divided by root of 1 positive t squared. So you can flip this, right? This can be flipped, the root 2 there. So it is going to be log root of 2 times 2 positive root of 5 the whole squared divided by root of 1 positive root of 5. Fair enough. I'm going to multiply by 2 divided by 2. So this is going to be 2 times the dt 1 over 2 times the root of 1 positive t squared, limits are 1 over 2 to 2. Now let me consider this integral. I'm going to consider integral 2t dt divided by root of 1 positive t squared. So I take 1 positive t squared to be as some u squared. So this is going to be 2 times dt is equal to 2u du. 2 gets cancelled. So in fact I don't know, I have to cancel it. I'll just retain it as it is. So in place of 2 times dt, I will place just 2u du divided by root of u squared. So root of u squared is u. So this u gets cancelled with this u, giving us 2 times integral du, which is going to be 2 times of u, which is going to be 2 times the root of 1 positive t squared. So the limits have to be substituted 1 over 2 to 2. That is the limits there. So you substitute the upper limit, you get root 5. You substitute the lower limit, you get root of 5 over 2. Right, 1 over 4, that's root of 5 over 2. This is what you get. Now this can be rewritten as, in fact, you can take the LCM. So 2 times the root of 5, negative root of 5 divided by 2. This is going to give you 2 gets cancelled. From 2 times root of 5 you take away root 5. Okay, so that will give you just root 5. So this integral reduces to just root 5. I hope you are watching this. So go up over here and substitute that value. So it is going to be log root of 2 plus root of 5 squared divided by root of 1 positive root of 5 minus root of 5 over 2. So this is what you have got, and the log is hitting everything, so that's understandable. So base e is placed here. If you want, you can place a huge parenthesis there just to show the logarithm is hitting everything. So this is the solution for this question. It's a lovely question. Please like, share and subscribe. Thank you.